Ladies and gentlemen, dear colleagues, it's my great pleasure to welcome you to the first joint seminar of the Polish Economic Society and the Italian Economic Association. I extend warm welcome to scholars from Italy and Poland, experts from the International Energy Agency and other international institutions, practitioners and policymakers, and to all of you who have joined us online from across Europe and the world. Allow me to briefly introduce the organizations behind today's event. The Polish Economic Society is the oldest and most distinguished association of economists in Poland, bringing together academics, researchers, and policy experts in the field of economics and economic policy. The Society has a long-standing commitment to promoting international scholarly exchanges. The Italian Economic Association, Società Italiana degli Economisti, is a prestigious academic society with rich tradition uniting economists from universities and research institutions across Italy and the world. It is one of leading academic organizations in economic sciences in Europe. Today, for the first time, we gather as two economic societies, Polish and Italian, to engage in joint scholarly reflection on one of the defining challenges of our era. This is a symbolic act confirming that European academic cooperation is not only possible but essential. Poland and Italy are important European economies, share a common interest in shaping European Union raw materials policy. Through the exchange of knowledge between our academic communities, we hope to contribute meaningfully to building resilient and sustainable value chains across Europe. I trust that today's meeting will commence an enduring cooperation between PTE and CIA, Società Italiana degli Economisti, and will inspire joint research projects. The subject of today's seminar is critical raw materials, a topic that has moved to the very center of attention for policymakers, economists, and security specialists around the world. Critical raw materials, from copper, lithium, and cobalt to rare earth elements, graphite, and boron, are the backbone of modern technologies. Batteries for electric vehicles, wind turbines, photovoltaic installations, semiconductors, and telecommunications infrastructure, plus a wide range of defense applications. The security of their supply has become a matter of strategic importance for the European Union and its member states, while price volatility, supply chain bottlenecks, and geopolitical concerns pose a serious threat to competitiveness and energy security. The purpose of today's seminar is to jointly examine the strategic importance of critical raw materials in the context of global economic dynamics, European policy framework, supply chain security, and ongoing technological transformations. Before we proceed to the substantive part of the seminar, allow me to introduce our speakers. Professor Simona Iammarino is Professor of Applied Economics at Gran Sasso Science Institute in L'Aquila, Italy, and visiting professor at the Department of Geography and Environment at the London School of Economics and Political Science. From 2009 to 2022, she was Professor of Economic Geography at LSE, where she also served as head of department and member of the LSE Council. Her research focuses on multinational corporations, globalization, innovation, global value chains, and regional development in the context of economic transformations. She has published over 70 articles in leading academic journals, and has extensive experience in international research and consultancy projects for the European Commission, the OECD, and the United Nations. In 2024, she was awarded the ERSA European Prize in Regional Science and the Giacomo Beccatini Prize. Dr. Miłosz Karpiński is an energy security and critical minerals analyst at the International Energy Agency. He is responsible for energy security issues with a particular focus on the resilience of supply chains for critical minerals. He is the author and co-author of numerous publications and has led and contributed to energy and mineral review missions across many OECD countries, including the US, Canada, Norway, Japan, and Korea. His research focuses on assessing how risks related to energy security and critical minerals influence energy policy design and implementation. Justyna Tomala is a researcher at the Department of Entrepreneurship and Innovation at Kraków University of Economics. Her research interests focus on sustainable development, eco-innovation, critical raw materials, energy economics, and the challenges of the energy transition. She is a member of several scientific and professional organizations, including the European Association of Environmental and Resource Economists, the Polish Economic Society, and the Chapter Zero Poland. She has participated in several projects funded by the National Center for Research and Development and the European Commission. Agnieszka Pagurul is a professor at Kraków University of Economics. Her research interests focus on energy and environmental security, energy transition, European Union climate policy, international commodity markets, and sustainable development. She is the author of numerous academic publications and has carried out teaching and research at several European universities, including Cologne International Business School and Universitat Nebrija. Ladies and gentlemen, before we begin, please take a moment to note a few organizational matters. The seminar will be conducted entirely in English, including the QA session. All participants are kindly requested to keep their microphones muted during presentations and to unmute only when taking the floor. Questions for the speakers should be submitted via the Zoom chat function, or for those wishing to ask a question verbally via the raise hand function. Questions will be collected during the presentations and addressed collectively in the QA session at the end of the seminar. Should you experience any technical difficulties, please contact the technical organizer via chat. Each speaker has approximately 15 minutes for the presentation. A QA session will take place at the end of all four presentations, and this is the end of technical introductory part. Now it's my great pleasure to give the floor to our first speaker, Professor Simona Iammarino from the Gran Sasso Science Institute and the London School of Economics and Political Science. Professor Iammarino will present a paper entitled Critical Raw Materials and Technological Transitions, the Role of Domestic Supply and the Position of the European Union. Professor Iammarino, the floor is yours.
Thank you very, very much, Alexander, and all colleagues from the Polish Economic Association. I'm really pleased that this is our first joint formal event after we signed the Memorandum of Understanding between the two associations in January. So without further delay, because I and all my colleagues have a lot of things to say, but let me share. But we have a relatively short time, and so we need to proceed very fast. Are you able to see my
Yes.
full screen?
Yes.
Yes.
And you hear me properly? Fantastic. So this is a theme that is very much at the earth of my research, and so I'm particularly pleased to share this interest with the Polish Economic Society. And so the topic I will talk shortly about today is the importance of the role of domestic supply in competitiveness, both export and technology, in for renewable energy transition that is based on critical raw materials. So this presentation will have a very, very short background since I'm the first to start on the topic. Then we'll look at critical raw materials and this renewable energy transition in particular with the role of domestic supply, and very briefly on the European position and our worries as economic geographer or economists in general terms. So why critical raw materials? This has been said by my colleague, Professor Serday. These materials are the vitamins, the spices for industries. They are used in micro quantities, but their properties and functionalities for technology, new technologies are fundamental. The shift to zero carbon, digital transition, so both green and digital transition have resulted in an increasing demand for these critical raw materials that is now exploding. However, on the other hand, we have high and growing supply chain risk, global value chain risk, particularly those based on these materials, as we have seen from different disruption of the global economy, from trade wars to actual wars nowadays. So in this paper that I will touch upon only very briefly, normally I don't present published work, but this paper has been out on technological forecasting and social change, right, 18 days ago, and I didn't expect that. So is with my co-author George Lee, and it looks at how material supply conditions influence two sectors of the renewable energy industry, in particular solar and wind, in terms of competitiveness of product export and technological advantages across countries, okay? And we use data integrated on the one hand, the UN Comtrade, and on the other hand, the US PTO for patents, and estimate this effect of domestic critical raw material production. Production I have to specify because it's a very central point. Production of processed critical raw materials, or even polished critical raw materials after extraction, after metallurgic processing and refining, but independently from the source of raw materials and ores. So raw materials and ores can be extracted anywhere in the world, but then the producers is those that, produce the input or the material that is cleaned. Why we will see very shortly, the main findings are that domestic production of this material supports the development of the export and stimulate technological output in the two sectors of renewable energy, and also mitigates international supply shocks, price shocks, and is enhanced by local competence in material technologies. So the relevance of these materials has been growing, particularly in the last 3-4 years. So the Critical Raw Material Act of the European Commission was published in 2023, and all the strategies that you see around 2023, also G20, and what we have seen in the last years, I would say the last 3 or 4, is a sort of boosting and booming of, unfortunately, tariffs, wars, constraint to trade, disruption of global value chains, and raising interest across the globe, also across continents. Now, The paper is based on a conceptual framework on which we have been working for a long time, which is based on the concept of technological regime in the tradition of evolutionary economics, Nelson, Winter, Dawes. So the technological regimes are the properties that overseen the evolution of industries and obviously change across industries. And on the other hand, this intersect the material base. So in a way, we have material science interaction with the knowledge base of the technological regime, the technological opportunities that are higher, the higher are the technological functionalities of the material, and the approvability, so the opportunity in terms of economic terms, are obviously linked to the material availability. So the renewable energy is an industry that can be defined as a material-based technological regime governed. And this can be seen across many different examples. But here I show very quickly, on the one hand, the share of patents in renewable energy versus all the others. You can see that are classified also as material technologies. It's well known that each patent is classified according to different categories, and you can see that the share of renewable energy that are classified also as material technologies is much higher than for others. And on the other hand, the share of patents that use critical materials is much higher than in other technologies. So it's definitely what we saw as a material base. Now, these are the countries that can exemplify what is the difference between production share, so what the country in fact produces in terms of both raw materials, but also processed after metallurgical transformation and refining. And you can see a very simple fact: China is the chief producer in the world, not only because they have their own reserve, but as this graph tells you, is that production is much higher of reserve share. So this means that the control of sources of raw materials is far more pronounced than in any other case. On the other hand, countries that are rich in materials, among which also Poland, actually do not produce the final input in the industry for lack of competence, lack of control of other, and so on and so forth. So the main findings will talk. This is the geography of the critical raw material production that is related to solar and wind. You can see China as a chief producer worldwide. You can see that there are some expertise somewhere else. Obviously, these materials are some in specific and not the 65 materials that are on the list of the major economies. So among which gallium, indium, tellurium, molybdenum, cadmium, selenium, and silver, which is not a critical raw material. But anyway, you can see that the map is rather clear, and we look at all countries in the world. So the model, the variable, I'm not going to spend time on this. I just wanted to share with you the fact, that we look at the impact of domestic critical raw material production. So basically the summation of all the share for each critical raw materials in country I and in the two sectors, solar and wind J, in each year, on the comparative advantage in terms of export and technological advantage in terms of patents. Then we have a lot of key regressors that are important, the global price shock that is given by the global price of the material and weighted by the intensity of utilization of that material. The share of material technologies patents, because it's a very important aspect, and other covariates that go from feed rate, which is the feeding tariffs, government support to production, demand condition, competition from other fossil fuel energy sources, general economic development variables for each country, and then for the competitiveness in export, we also control for technological capability and specialization. We have different models. Of course, we have problems of endogeneity, because if you have a very high development of the RE sector, this can stimulate metallurgic smelting industry and therefore increase production. There might be a lot of unobservable variables that influence both dependent and independent variables, such industrial policy, proximity to other producers, related industrial activities. And so we devised an approach of instrumental variables to alleviate this concern that is based on the geological reserves of critical raw materials, based on the US and British geological survey, and this geological reserves are given in a way exogenous by nature. So this is our strategy. The paper is there. The main contribution is to show, in fact, that beyond geological endowment, even if you don't have these materials under the ground, being able to produce them is actually very important, and hence value chain stability, strengthen industry competitiveness overall for the country. So not only in terms of production and exports, but also in terms of technological capabilities. Re-establish all this, the importance of national resources in economic development, growth, and technological progress, which is not a total news in human history, as we know, but it's probably characterizing the technological paradigm, digital green, that is currently in transition. So we offer a conceptual framework that we think is quite solid, and there are also obviously a lot of redistributive welfare and development opportunities across regions in the world. We are working at different level of geographies, also at the regional level, and we are working also at the firm level with my group of co-authors. Now, to get to the EU and how this connects to what I've been saying so far, and the importance of producing and being able to produce the inputs that go into the high-tech industries, and particularly the industries that are important for the green transition. I mean, the EU, as we all know, has set this benchmark, okay? Benchmark that are extraction, 10% of the EU consumption should be extracted within the EU, 40% should be processed within the EU, independently from where the materials are extracted. EU recycling now has gone up, but initially was 15%, but now it's 25%. So at least this should come from recycling within the EU. And then there are constraints to export and reliance on a single source, a single country for more than 65% of a single material. And we know that this dependence is sometimes much higher, okay? 97% of magnesium has been sourced from China, 63% of world cobalt is actually located in the known deposit in the DRC, and so on and so forth. But from the geography map that I showed you before, this is interesting, and I forgot to tell, I want to just show that Africa is white, okay? Africa doesn't appear on the map, although very, very rich in this material, because its capacity to produce, so to refine, to process, and to arrive to the final input for industries is not there. And it's obviously quite important to understand the control of these materials. What are our worries? Very quickly, material scarcity in the territories of the European Union, with a few exceptions. Poland is among those, but there is scarcity. Long-term massive investments are required. So even with those benchmarks, to arrive to mines, operating mines, it takes a span that goes between 5, 10, and 15 years, depending on the geological condition of the material. We have a second worry that is related to the fact that these are natural resources, so very specifically positioned in space. So we cannot say Poland, but in fact is a very specific region in the northwest of Poland, for example. And therefore, there is a problem of social license to operate, a problem of, not in my backyard, and, the geographical impact in terms of environment, cost of social cost and human rights cost outside, for example, the EU, are quite localized. And finally, the EU open strategic autonomy and other countries' strategies. The EU has been talking in terms of like-minded countries that at this stage of history is very difficult to understand who they are, and possibly another missing opportunity, particularly in the continent that is closest to us, which is Africa. Just to show you this worry in 1 minute, you can see that the EU, here is just 3 of them, okay? We are working on S&P global data and geolocalizing everything. And we can see that the EU is not rich in platinum, cobalt, lithium, but this is unfortunately the situation for most of this material. The social license to operate. Now, obviously, in the countries that are rich, there are severe effects in terms of, these are disruptive mining and exploitation of these materials are disruptive in terms of water pollution, soil pollution, biodiversity destruction, human rights, as we know. But also in the EU, we have had, and right outside the candidate countries, a lot of protests of communities that, there are costs and benefits to be calculated. And finally, missed opportunity. Well, we know that, China has been controlling the sources, particularly with investment in Africa and also Latin America. But I repeat also this, the first summit with all, at least 34, if I'm not wrong, African head of state talking about critical raw material was organized in Beijing in October 2000. It's more than a quarter of a century ago, while Europe has been busy in other things and missed the train. Obviously, nowadays, the African countries and regions are much more aware, and some of them also growing very fast and putting in place strategies that try to prevent the extractivism that they have been seeing for a long time. So these are the references, and thank you very much. I hope I've been in my time. Thank you so much.
Grazie, Professor Iammarino. You have raised our interest in reading the full article. Grazie mille. Now, I would like to invite Dr. Miłosz Karpiński, Energy Security and Critical Minerals Analyst at the IEA, to take the floor. Miłosz will present his paper entitled Global Critical Minerals Outlook 2030 and Beyond. Dr. Karpiński, please go ahead.
Thank you, Mr. Professor. Thank you very much for this invitation, especially, and thank you for other speakers. Professor Iammarino, fantastic, inspiring presentation. Thank you for this. I will try to look a bit on this topic from a purely energy point of view. As we, as the International Energy Agency, we mostly focus on energy implications of critical minerals and actually how they then transfer onto economic security. Because without any doubts, if I may start now, I hope you see my screen. Without any doubts, actually, today, energy security is just no longer some technical operational concern alone. It's more than that. It's kind of a fundamental pillar of national security for many countries, for most of modern countries, but also it's a pillar for economic stability and social well-being. The latter one would go a long way towards affordability, of course, and access to energy, which is still today a big problem in many countries. We, just for this one, we calculate that some 1.5 billion people around the world still lack access to electricity today. It's just that much, and some more than 2 billion have to rely on like very simple cooking devices to prepare meals. But this aside for now, and just like how maybe to warm up how the situation which we are seeing today in the Middle East is also impacting critical minerals, because it does. At least for aluminium, as you see on the screen, sulfur and others as well. But one of those others is, for example, helium. We don't talk much about helium, but it's like Qatar had always been a second global producer of helium, which, for example, is used for cooling of nuclear reactors. So it's extremely important, also mineral in the world. Just to say, as we're talking about a bit about Poland, Poland is the only producer of helium in Europe, although in very small volumes. The next one, actually, I will try to explain with this slide why, in fact, we are talking about critical minerals today and so much since like some years. At the IEA, we've taken on this topic since a good 5-6 years. And it was evident back then that it would be coming a big time to our attention. And today, if we follow energy or climate debates around the world of policymakers, this is actually one of the most important topics on top of agendas of policymakers around the globe. But why so? It's all about electricity and electrification. As we see on this chart, electricity is the fastest growing source of energy globally. It's been the case already for some time, but going forward to 2035, we see as much as 35% of growth in electricity use in comparison to today. It may not seem that much. It's a bit more than 1/3, but it's only 10 years from now. And the other thing is that actually we would have to add like US and Japan combined consumption to today's global generation. It's a huge amount. As Madam Professor Iammarino mentioned, renewables is one of the driving factors behind interest in critical minerals. And of course, in fact, as you see on the right side of this chart, as we see things going forward over the next 10 years and also beyond, these new uses will also add almost like 1/3 to current consumption of electricity. As we see around the globe, electrification is driving force behind many energy happenings. Like today, we see, of course, electric vehicles, but also the huge deployment of renewable energy sources. All of them are based on critical minerals. Not only this, but also if we think about grids, which is the single biggest challenge for energy sectors worldwide today. Grids are based also, like developing them, building them, is based on critical minerals as well. This is so much important today. At the IEA, we mostly try to look at like 6-7 most important minerals, which is like copper, lithium, cobalt, graphite, nickel, and of course rare earth elements. But as you see on the screen, we've attempted to analyze 20 of them, which are important for many different applications, also defense, medical, as Madam Professor already mentioned, and many others, like today, like IT, telecommunications, AI, of course, and data centers, which are again a driving force to increase consumption of electricity worldwide. This is actually maybe a chart which is very much an eye-opening to many, because out of those, Madam Professor mentioned about some challenges and worrying elements of this sector. We call it straight an opaque market. Today, if we add on elements, critical minerals worldwide is an opaque market without actually any rules, any price benchmarks. So also without any standards to them. We saw pictures in Madam Professor's presentation, indeed child labor, but also forced labor. On top of that, of course, no concern to environmental standards as well in many parts of the world. This makes it so much difficult to navigate, while actually we need them all and very quickly, very soon. This chart, out of 20 minerals we analyzed, 19 are purely dominated by China. And then nickel is, of course, Indonesia is a nickel country. But then again, if you think about Indonesia, 75% of nickel output is owned or controlled by Chinese companies. That shows actually this concentration today. Next one, actually, as we see, I will run quickly through this. We see different elements of economic sectors and supply chains here for different applications. And then actually, if you see on those, it's either China or China and export controls subject minerals. It's so much today important. As minerals are important not only for energy, but also for economic resilience, many other elements. This is so much telling about where we are today, actually, what is the state of play today when it comes to critical raw minerals. The next one actually is, because sometimes it may miss our picture, this is very much depicting what is, in fact, the complexity of supply chains for critical minerals. If we look at this, it's, of course, it's mining. It's the first thing, and supplies. It's sometimes it's also like very important to somehow open our eyes to what it means really to produce solar panels, heat pumps, modern electric vehicles, and of course also wind turbines, data centers, AI chips, and what have you. This is actually mining. So we try also to introduce this very explanatory way of thinking to all of us. If we really want to have clean energies deployed widely, we have to somehow address what Madam Professor mentioned already, this social license to operate. No one wants minerals mined in their vicinity. It's all over the world, actually. I've led reviews of countries, US, Canada, recently Norway, Portugal, Poland. In December was a very good review in Poland. And actually, from the political point of view, we all need minerals and we want them produced domestically. But then again, if we ask societies, regions, they don't really want that. Everywhere from US to Japan, opening a new mine for whichever of minerals is like between 15 and 17 years. That's a delay in supplying markets today. We go along the value chain, actually, and we have to see from the beginning what we actually have done for decades now for oil and gas. When we commission any production site or any like refining or smelter of this supply chain, we need to think from the beginning about decommissioning through recycling and then also decommissioning of the site. That actually will help us all, because what we hear everywhere in the world, this is today's approach of societies, especially like in the US, Canada, but also elsewhere, like in the whole of Africa. When we ask societies why they say no to new sites, it will bring jobs, it will bring prosperity, possibly. They told us that they've heard that already from many stakeholders 50, 60 years ago when they came for oil and gas. They came, they destroyed the land, they disappeared without actually leaving much behind of the wealth acquired through exploration. That's what we have to also see through this opacity of the market today. Then the next one actually, and also like to see, because mining is one thing, but then also refining is what really makes the market so much concentrated. Professor mentioned about DRC Congo in her presentation, but indeed, maybe this example will also show us some problem which we have today with cobalt, for example, from DRC Congo. As we saw, 65% of cobalt used globally for electric vehicles batteries is coming from Congo. But actually it is not, because in Congo they only produce like cobalt stones. It's like rock, cobalt rock. It has to be heavily refined and processed to arrive at this full-digit purity cobalt, which we need for modern applications. So what is happening to those rocks from the DRC Congo? These are loaded, of course, after being mined by often with child labor and forced labor, or at best case scenario, very low paid labor. They are loaded on, of course, heavy fuel propelled barges, and it goes to China. So it goes all the way through the sea from DRC Congo to China for processing and refining, and then only is supplied to the market by China then. So it's actually all these red colors, they indicate China, but also for nickel, as you see, this refining is at least controlled, owned by Chinese companies in 75%. This is the state of play today. There may be like a very simple element today. When we see forward-looking, forecasting demand for next 10 years, we see clearly that for most of most important minerals, the supply-demand gap is very much widening. This one, actually, this chart is actually showing very much that what actually we are lacking in 10 years from now is some good 30% of minerals needed. So, of course, when supply will not meet demand, we may, of course, very easily see what consequences will be there in place in 10 years from now. It's all from our side, from the IEA, to also to propel investments and actually to see that this is maybe, it's not the best moment maybe to invest because of different global obstacles. But then again, if we don't invest today and seeing delay of investments like good 10, as mentioned, also 17, up to 17 years, it has to be happening very much now. Export controls is the same thing, actually. I'm happy to share these slides with participants, but actually it's very much also telling one country, be it China, but be it Poland or Italy, is always bad for diversification. The golden rule of energy security is diversification, but it's also a golden rule for many other, like even investments, is diversification, while it's not actually really possible today with this market environment. Maybe two words about rare earth elements before I close my presentation. They are called rare earth elements, but in fact, they're not that rare. They're pretty abundant in the Earth's crust. But then again, as they don't appear, but the professor would be, of course, happy to add some details to that, as they don't really appear, or they are not really found in like individual deposits in the world, they need to be found through like very heavy mining as some tail remainings or some small elements, tiny fractions of what actually is mined elsewhere. That's why I call rare elements. But actually, they may be not that much important for all of us. But if we see this chart, we try to count that. Well, we are data-driven organization, so we try to come with numbers for everything. What we are saying, this actually is showing very much that all of these crucial today's economy or like energy industries, they need rare earth elements very badly. But also it's money. It's all actually about money when it comes to critical minerals. Rare earth minerals is some $6 trillion business today, yearly. That's why actually this competition is growing, and actually we may also see a bigger competition over those minerals going forward. To close my presentation, maybe like one, again, possibly striking information. Back in 1986, US was the biggest producer of critical minerals. But since 1986, China took over. We learned globally, publicly about that some 10 years ago. But in fact, China invested heavily in critical minerals in 1980s. That's how long it took them. So it's not surprising today that as others dropped the ball, China took over, and now they are leading in not only minerals, but also, as we know, in many, many other elements of economy globally. This is happening now. Question actually what we do next to diversify is what Madam Professor mentioned already. We have to see some domestic production. It has to be well organized. We need to see maybe some better organization. We sometimes give, that's my last sentence, we give example of blood diamonds in 1980s. Today, we cannot find blood diamonds in the world. They were regulated. There's a traceability record for all of them. In fact, actually, it's almost impossible today to trade blood, so-called blood diamonds. We hope for the same for critical minerals because standards need to be set to see some maybe bigger diversification. I thank you very much for your attention. Thank you, Mr. Professor, for your invitation. My pleasure.
Thank you, Dr. Karpiński. Thank you, Miłosz, for your presentations, so rich in data and quite comprehensive for this small amount of time. You have also convinced us why it is important to protect international organizations such as International Energy Agency, because you are doing a very valuable job to many countries, and you help to build cooperative solutions to future development of global economy. Thank you.
I appreciate it. Thank you.
I now give the floor to Justyna Tomala, researcher at the Kraków University of Economics. She will speak about raw materials security in the European Union, the Critical Raw Materials Act. Justyna, please go ahead.
Thank you very much, Professor Surdej. As Professor Surdej just mentioned, I will focus mainly on the raw material security. I hope you can see my screen and also the full screen, because I use two screens. So let me check. Okay, it should work. So for the next I suppose 12 minutes we'll dive into the Critical Raw Materials Act. As Professor Iammarino mentioned, it was introduced 3 years ago by European Union. And then I will also expand some more data that was provided by Dr. Karpiński. But let's start with the raw materials security. The discussion about some geopolitical tensions and accelerating demand for strategic resources and increasing importance of resilient supply chains for green, but also digital transition, because within European Union we talk about the twin transition. Actually, I raised the questions about raw material security that might be defined as recurring phenomenon resulting from the uneven distribution of mineral resources in the earth crusts, which also leads to the dependence of mineral imports by countries that lack domestic deposits, as we've already seen during the presentation of Professor Iammarino, but also during the presentation delivered by Dr. Karpiński. In recent years, critical raw materials have become a central issue in a European Union, economic but also industrial policy, and their importance extends beyond traditional industry, as they are now fundamental for renewable energy sector, also batteries industry, defense technologies, aerospace technologies as well, and European Union introduced Critical Raw Materials Act in 2023 within the critical raw materials list, which is developed since 2011. So this is the fifth critical raw materials list provided by European Union, and every 3 years, actually, within 2026, we also should expect next critical raw materials list, so we can actually see that actually they are kind of important for twin transition, as I mentioned, but also what is important here with this critical raw material list from 2023, actually European Union also distinguished critical raw materials and strategic raw materials. So even though copper and nickel were introduced into the critical raw material list, they are no critical, but they are strategic resources for twin transition. Also, this list highlights the diversity and complexity of EU's resource needs, and the broad spectrum demonstrates that the transition into a low-carbon economy relies on an interconnected system of mineral inputs rather than a single resource, we can say. And the Critical Raw Material Acts actually aims to ensure a diversified and sustainable access to key resources within European Union, and it's introduced concrete benchmarks, as Professor Iammarino mentioned, including increased domestic extraction, processing and recycling capacities, alongside limits on dependency on single external suppliers. And the Critical Raw Materials Act represents a shift toward a more strategic and interventionist, let's put in that word, approach to resource governance within the European Union. The research objective of this presentation is to analyze the impact of Critical Raw Materials Act on the raw materials security of the European Union, with particular emphasis on the ability of this initiative reduce import dependencies to enhance the resilience of European supply chains for critical raw materials to geopolitical risks. For the methodology, I employed the co-occurrence analysis with use some of keywords set, Critical Raw Materials Act or CRM Act or CRM or Critical Raw Material or Raw Material Security or Raw Material Supply Security or European Union or EU. For this purpose, I used the Scopus database, which is actually applied widely within scientific research. And then the keyword co-occurrence analysis was conducted within the VOS viewer tool. In terms of results, the trends analysis reveals that research on critical raw materials and Critical Raw Materials Act is highly interdisciplinary, as we've already heard during the preceding speaker's presentation, and the strongest connections are observed between teams such as resource management, European Union, geopolitics, but also strategic raw materials, which kind of indicates the intersection of economics, policy, and international relations. As we've seen on a previous slide, actually, the co-occurrence analysis provided us 4 clusters. The first cluster, the red cluster, focuses mainly on demand dynamics, geopolitical drivers, market competition, and also reflect to the growing pressure on global resource market. As we already seen some charts provided by Dr. Karpiński, we've heard about the Chinese role. However, there was also maybe it's also worth to mention about Indonesia, which is actually kind of interesting that that country blocked the export of nickel, which is also crucial for battery industry. Then we have the second cluster, the green cluster, and the second cluster actually emphasizes governance, regulatory frameworks, and mining activities, and also shows that policy design and institutional agreements also play an important role in shaping raw materials security. Within the third cluster, we have the international cooperation and supply chain interdependencies, which underline the global nature of raw materials market. And with the fourth cluster, the yellow cluster, that concentrate on strategic raw materials and resource management, and also that cluster reinforce the idea that targeted policy interventions are necessary to address vulnerabilities in key value chains for critical raw materials. Also, what is important for European Union, and also this is a very important aspect of Critical Raw Materials Act, it's strengthening also the circular economy, because European Union aims to reduce waste and reliance on primary materials by promoting recycling and material reuse. And we can see that, for instance, with the Horizon program, where almost 600 million euros will be allocated to support the optimization of resource use in a circular economy and in new production processes. Then we have also some recommendations for strengthening material resilience. And actually, to effectively strengthen material resilience, European Union should complement regulatory measures with stronger financial and institutional support. And actually, this includes increasing investments in recycling and processing technologies, and also kind of bridge the gap that we have within the European Union. Also deepening the partnerships with reliable free countries, and streamlining administrative procedures. And for some concluding remarks, the Critical Raw Materials Act actually represent an important step toward European Union strategic autonomy within critical raw materials, but this act don't eliminate structural dependence on external suppliers, and actually it's also establish kind of the framework for managing these dependencies more effectively, and also combining diversification, domestic capacity building, and some circular economy strategic in an uncertain geopolitical environment, I would say. So that's all from my side, and thank you very much.
Thank you, Justyna. Thank you for your insights into CRMA Act, and thank you for presenting your approach to research into the debate around this act. Now it's time for Agnieszka Pach-Gurgul, professor at the Kraków University of Economics, whose research focuses on energy policy and raw materials. Agnieszka, your presentation is about the role of critical raw materials in the development of the hydrogen economy in the European Union. The floor is yours, please.
Okay. Ladies and gentlemen, dear colleagues, I would like to express my sincere gratitude for the invitation to participate in this seminar, which is organized by Polish Economic Society and Italian Economic Association and dedicated to the issue of critical raw materials. So this seminar, I think, provides an excellent opportunity to reflect on the role of critical raw material, also in EU energy transition, and especially I want to focus on the role of critical materials in the development of the hydrogen economy in the European Union. So my agenda consists of 6 points, but general, the idea is to try to explain why the hydrogen is important for EU and why the critical materials are crucial for development of this technology. So first of all, I want to start from the European Union as a leader of the global energy transition. Then I want to introduce some new geopolitical context and the balancing between energy transition and energy security. Then I want to focus on role of critical raw material in hydrogen technologies and to show some facts about hydrogen production in the European Union. And well, I want to also focus on challenges associated with critical raw materials in context of development EU hydrogen economy. And then I want to conclude some facts, and I want to share with my conclusions. So first of all, we know that European Union has been a pioneer in global climate and energy policy, with its commitment to emission reduction, which is dating back to the Kyoto Protocol. And well, a key milestone for this energy transition was climate and energy package, which was launched in 2008, and it sets three main goals. 20% reduction in greenhouse gas emission, 20% share of renewable energy in EU energy mix, and 20% improvement in energy efficiency. These ambitions were further reinforced by the Paris Agreement, aligning EU policy with global climate goals, and then the European Green Deal established a roadmap towards climate neutrality by 2050. And more recently, the Repower EU plan has accelerated the energy transition in response to geopolitical challenges, especially Russian-Ukraine war, highlighting the growing interconnection between climate policy and energy security. So these initiatives caused some changing in EU energy mix. And I took some crucial points for this energy and climate policy in the EU. I chose the date from Kyoto Protocol 1997, and we see that the European Union tried to resign from fossil fuels, especially from coal, and we did it. Yes, we resigned. The share of coal dropped from 23% in our energy mix to about 10%. And of course, we increased the share of renewable energy sources from 5 to 22%. So we can say that these all politicians, all energy all policy measures, all these directives, all these documents, this document achieved in some way success. Of course, this is the coincidence of many factors, because we have COVID pandemic, we have some EU sanction on Russian commodity. So of course, this is, I'm sure that this is the result of our energy and climate policy, yes, but there were also some new circumstances which caused that we are in this point when we are talking about energy mix. And of course, this drop in carbon dioxide emissions. So it caused that EU is in some way a leader of global energy transition. But I think that a new concern appear, because we have recent developments, including the COVID pandemic, the war in Ukraine, ongoing tensions in Middle East, rising oil prices. So it have exposed the vulnerability of global energy system, and these events have led to supply disruption, price instability, and a heightened awareness of strategic dependence. So we know that these points cause that European Union come back to the issue of energy security, not only energy transition. So the European Union must now carefully balance these two issues, equally important objectives, yes, advancing the energy transition, but also in the same time ensuring energy security. And in this point, I would totally agree with Dr. Miłosz Karpiński that the diversification is the main thing And this is one of the most important things if we want to combine this two issues. From my point of view, in this context, hydrogen appears to be a particularly promising solution, as it can support both decarbonization from one side and energy security objectives. So this is a new geopolitical reality, and achieving this balance, it's very, very important thing for EU. And this is, I think, unsurmountable challenge for EU countries. And as I said, the hydrogen technologies and general the hydrogen economy, this is a good and promising solution. We know that the EU framework for hydrogen development is based on Repower EU document, which assume, among other goals, that the production of 10 million tons of green hydrogen by 2030. And we know that critical raw materials, Professor Simona and Justina also underline this issue, are highlighted in the new Critical Raw Material Act, and we know that there are also underlined that this issue connected with domestic extraction and recycling, and we know that particular importance is attached to important project of common European interest programs which support strategic investment in hydrogen technologies and critical raw materials, thereby strengthening the European Union industrial base and technological sovereignty. So we know that also in Poland, we realize many hydrogen project, Hydrosanok, or a project which is launched by Orlen. So we know that this is still developing technology, but importantly, the development of the hydrogen economy is directly dependent on access to the critical raw materials, which are essential for key technologies such electrolyzers, fuel cells, and renewable energy system. And I will explain everything for a moment. So we know that in this context, the availability and security of supply of critical raw material become a decisive factor for the successful and scalable development in the European hydrogen economy. And well, we have two electrical devices which are connected with hydrogen technology. We have proton exchange membrane electrolyzer and proton exchange membrane fuel cell. The first one, this is the device that enables the composition of water into hydrogen and oxygen using electrical energy. This process, known as water electrolysis, occurs as a result of an electric current passing through an electrolyte and the use of appropriate electrodes and a membrane separator. So when we look at the main structural material, we see that it needs nickel and also copper and also cobalt and the other rare earth elements. We can say that it's about 30% of nickel. And there are many supporting materials like graphite and the other rare metals. So we need to develop hydrogen technology. We need these critical raw materials. And also in this, the second device, so this is fuel cell. It's a type of fuel cell that use a polymer membrane to generate electrical energy from hydrogen. So it needs platinum iridium as a catalyst. So this is the main challenge of developing this hydrogen technology. But not only this, if we want to think about storaging and how to storage the hydrogen, we know that the hydrogen storage can take place in a high pressure tanks, steel, carbon fibers, which are not generally consider with critical raw materials, but it can be also through chemical methods. So in the case of solid oxide electrolyzers, high temperature electrolyzers, the main components contain cerium, vanadium, and these are the critical raw material list. And it's also important to note that demand for batteries supporting hydrogen infrastructure, lithium-ion batteries introduce additional raw material challenges. So it's necessary to have the access to these critical raw materials if we want to diversify our EU energy mix. And we know that it's really difficult to develop this technology because we have many types of hydrogen, and our European dream is to produce only green hydrogen. So using just renewable green electricity, yes, which is taking from renewable sources, but it's really difficult. The blue hydrogen, so this is the hydrogen which is being produced from a fossil fuel with carbon capture storage. It's also very expensive technology. So we, for example, we produce hydrogen from gas, and we put these carbon emissions underground. And gray hydrogen, I would say it's the most popular. This is also hydrogen produced from fossil fuel, but without carbon capture storage, so without this option putting carbon dioxide underground. And we have non-classified hydrogen. This is byproduct hydrogen. And today, how it's look in EU, according to the newest data, we have some leaders, also Poland and Italy, yes, but the colors of this hydrogen, as I mentioned some minutes ago, yes, we see that the gray, it's the most popular. And of course, if we look at the map, yes, we clearly see that, that currently hydrogen is still largely produced from fossil fuels, especially natural gas. However, the EU is making significant efforts to shift towards more sustainable production methods, primarily through water electrolysis, powered by renewable energy sources. So we try to achieve our goal, but it's really difficult, and it's still expensive solution. And we see that, yes, we want to see on this map just green points. Yes, so maybe in the future the dream will come true. Yes. And in this context, technologies such as proton exchange membrane electrolyzers play a crucial role, as they enable efficient and flexible hydrogen production, particularly in combination with renewable energy. And at the same time, scaling up hydrogen production requires substantial investments. Yes, Justina also mentioned about these investments, technological innovation, and importantly, secure access to the critical raw materials. And this is very, very important in context of this technology. And we see that this is not only a challenge, this is not only technological challenge, yes, but we know that it's also strategic issue. And we know that maybe European Union 10 years ago too much, maybe we focus on just on the climate issue and just on the energy transition. In the same time, we should diversify our energy mix. We should implement new technology, new energy solutions. We know that the energy security is a part of national security, yes. So, and the part of sovereignty of the country, yes. So these are very important issue for us. And what are the challenge for critical raw materials in the context of the development of European Union hydrogen economy? The EU imports most of its critical raw materials from external sources. Professor Simona, Dr. Miłosz Karpiński, also Justyna underlined this fact, and we know that it can be risky solution, yes, because we think about this supply chain, about the bottleneck, and it has a huge influence on hydrogen development of hydrogen technology. Yes, so this is a quite unsurmountable challenge to have access to this supply of these critical raw materials, but also recycling and circularity. We know that according to the EU raw materials strategy, recycling is becoming crucial. For example, the practical recovery of platinum from fuel cells or lithium from battery is still only a limited scale, but there is growing pressure to expand these processes. The EU is introducing recycling obligation and investing in innovation. And we also think about this circular system, which can reduce the dependence on the import and in some way help protect the environment. And this is one of the favorite slides, because it shows us that we have some success. Yes, so we are thinking about combine different technologies, different issue, because here we have the examples of projects which combine hydrogen technology and critical raw materials and some renewable energy sources. So we see that we as a Europe want to create some chain which will grant for us some environmental friendly solution and will grant especially energy security. Yes, so we see the European Lithium and Magnesium Alliance, development of European lithium mines, Spain, Germany with EU support. We see BLAM project. So this is the hydrogen in Poland. KGHM Polska Miedź invest in fuel cells and nickel recycling with a local partner supported by EU grants. Power to X project. This is Green Netherlands. Hydrogen electrolysis powered by photovoltaic and hydrogen storage. And I think this is in some way key for success to combine different technology, different solution, but as I said, the critical raw materials are necessary, and it's huge challenge to have still access to these materials. So we know that, to conclude, critical raw materials are essential for a secure and sustainable hydrogen economy in the European Union. European Union must actively secure access through diversification and investments also in recycling. Strong policy initiatives such as the Critical Raw Material Act, an important project of common European interest, represent a step in the right direction, but consistent implementation is required. EU industry cooperation is crucial. Joint demonstration project and educational programs, I think this is, yes, very, very important. And we should accelerate investment in critical raw material value chain for hydrogen and to urgently implement standards for sustainable extraction. In conclusion, the development of hydrogen in Europe depends on access to appropriate raw material. EU countries and companies must act jointly to avoid bottlenecks. The potential of our hydrogen market is enormous. If we focus on innovation and strategic partnership, the European Union can become a global leader in hydrogen economy. Thank you for your attention.
Thank you, Agnieszka. Thank you for insightful presentation with elements of chemistry. We have only a few minutes left as we have promised to close at 3:30. So maybe there will be questions, but I have anticipated this situation of shortage of time, and I have just two questions to our foreign Paris-based and Gran Sasso-based speakers. So to Dr. Karpiński, you are a close collaborator of Executive Director of IEA, Fatih Birol. So could you tell us what the IEA prepares, what is coming as a valid product prepared by the IEA? And to Professor Iammarino, my question is simple. We are working in academia, we are researchers, but what kind of links you see between new areas of research and public policy applications? So who will start, Miłosz?
Thank you. Thank you for this question. I will be very brief. So in fact, we may divide our work at the IEA in three parts. So one is ongoing, and it's been ongoing since a good 5-6 years, deep analytical work on critical minerals. 2 days ago, on the 8th of April, we published a very thorough, I think, analytical piece about rare earth elements. This is like available on our website. It's for free. It really may add to bring some points of discussions about those precious metals around the world. That's one part. So actually, we do analytics all the time. Next one will be about copper, because actually, if you ask us about the most important critical mineral now, it's copper. Because we see, and actually here Poland is very much important as a leading producer of the world, as a 5th biggest producer of the world, with KGHM being present not only in Poland but also in Chile, in Canada. What's important here, Poland discovered recently, KGHM, probably the biggest new copper deposits globally since good 10 years. That's important. So analytics, that's first thing. Then also what we try to do, because actually, of course, we have to provide some tools, some solutions to this global lack of opaque markets. And actually, that is one thing is we are building this, what we call critical mineral security program. And the biggest part of that is advanced already work on preparing a global stockholding mechanism for critical minerals. Like we did for oil in 1974 as the IEA, we want to bring also this issue of critical mineral stockpiles to balance out markets in times of need. And third element, which probably is most visible, we try to really match, and through Dr. Fatih Birol, our head, we try to advance the topic of critical minerals, also adding to global discussions about how actually this market can be or should be organized further to avoid huge disruptions in the coming years. So in a nutshell, these three elements, and please also to all participants, be welcome to our website and our publications. They may really bring some data, but also some factual elements to discussions. Thank you.
Thank you. Professor Iammarino, please.
Thank you. Very interesting presentation, really inspiring. And I mean, I don't want to put myself in the guru position, Alexander, in the sense new areas of research in public policy can go from, demographic problems to public services as important as health and education that are becoming more and more financialized and privatized. And so there are many, but it's not my area. My expertise suggests me that, we need more and more focus on equity and inclusion within the union, because with the current trends, let's call it this way, it is very important to ensure balanced development and cohesion within, but also maybe also to look a bit more outside, because in my opinion, the union has been rather introvert and inward looking without maybe engage more towards a new kind of international relations and models of mutual sustainable development with the global south. And this relates again to what I was saying, critical raw materials or whatever. I mean, a step towards the transition, green, digital, particularly the green climate change. And we really need to be aligned with all countries, and to include this division of like-minded. I don't know if it is the right approach, but rethink our relations with the rest of the world as Europe, because it can help us more than anything else.
Thank you. I think we have no time, and I will not dare to summarize this seminar. I can try to tell you what I have learned, but it will take another 15 minutes, so I will keep it a secret. I have written my notes, but I would like to thank all speakers that have brought to us these critically important critical raw materials. And I would like to also thank the leadership of Società Italiana d'Economia of Atto Nero, the Italian Economic Society, for supporting such cross-country initiatives, which are always a start point for another venture, another organizational efforts and maybe research. So grazie mille. I hope it's not the last time we are meeting in this mixed Polish-Italian environment with incursion of Paris and international organizations. So hereby I am closing the meeting, the session.
Alexander, just to say that we have a common session organized at the CEA conference in Cagliari, and for sure we have already a topic for the next workshop. So we'll proceed together for sure. Thank you.
Ci
Thank you very
vediamo a Cagliari. So thank you, and this is the end. Thank you to all. Thank you.
All the
Bye.
best. Thank you.